Hello there. Today we are gonna start a long project. And it's gonna be a very slow burn to begin with. So don't get too excited for things to happen very quickly here. Let me explain what I want to do and how we are going to go about this. Because I really want a product to exist that would be really convenient for some of the things that I do, and I think I'm going to have to be the one to make it. So, let me cover the basics of the problem, okay? I have a grease weasel right here, and I have it connected to a Tandon TM102A. Okay. So this is a 40-track drive. We can use it to image floppy disks and all of that. I would like to be able to clean this floppy drive right now. I need to go over to a computer. I need to plug it in. I need to run the clean command, and then it'll start spinning the drive there. Now, what is that doing, actually? Well, that's holding high one of the select lines and one of the motor lines. And I'm using a computer for that. For why? What possible reason? If the drive has power, really all I would need to do is just flip two switches and then I could get the motor spinning like that. So it'd be pretty easy to just do that externally. And this gets into a bigger concept of external things, like say the floppy switchboard that I made. So this you connect, again, just a switch. And what this does is toggle two positions between the motor and select signals for the drives so that you can expand your floppy cable interface by one drive per switch. And that's pretty convenient. But what I think I would like to do is take this concept and just maximize it. So here's what I want to do. I want to create what I'm going to call the floppy interposer. And it will have connections for at least, but probably at maximum, 2 grease weasels. It will have 4 floppy connections going to those grease weasels. And then this is one of the things, I mean, let's just make the numbers vague, okay? Some number of connections. One of the things the grease weasel has on board is regular GPIO pins that you can control, I believe. And it might be possible to use those to activate switches to change drives outside of the standard wiring. So I want to investigate that. But I'm also thinking that it might be beneficial to just throw my own, literally throw my own microcontroller on this board, and then I could do something like a computer-free drive clean routine by just telling it to spin the motor. If it's an 8-inch drive, load the head, pop the disk in, start it spinning, and all that kind of stuff. So I kind of want to do some investigations today to just figure out what we can do with directly interfacing to a floppy drive and kind of come up with a concept of what this project will ultimately be. So that's the goal. Today we're just doing investigations, and from a product design perspective, where my professional experience actually comes from, I would call this looking for unknown unknowns. So an example, let's say you have no pre-existing knowledge of aerospace engineering, okay? And you look up into the sky and you see the moon. You want to go there. You could conceivably think, I'm just going to make a really tall ladder and just climb my way there. But an unknown unknown for you is that there is no air up there. You have no way of knowing that. You've lived your whole life on the ground. There's air here. You would have no reason to assume that there isn't air in space. So that is the kind of thing that I want to discover today. I want to look at, can I step the head of a floppy drive with a simple signal? What are the logic levels for the motor select and motor activation? Or they're not doing anything dumb like negative voltage nonsense, right? So I want to look at what all we can possibly do and then try to come up with concepts. And one of my goals today is possibly to lay out a development board. So it's not going to be a final board, but it would be a board that helps make this process easier, because one of the things that I did this morning in preparation for this stream, as an example, the kind of thing where a development board would be helpful, is I soldered 3 different IDC headers together here to bridge over a breadboard so that we can actually measure the signals from a floppy interface here. And I want to be able to connect the HP 16500C logic analysis mainframe there to it. So that's one of the goals for today, so that we can watch timing and things to figure that kind of stuff out. So that's what I want to look at. And Hellecraft, I know you say everything is TTL, and I have no reason to doubt you, but once I get in here and start investigating things, it might lead me to discover some other things. Like, I go in here and I start poking around stuff. I tell it to spin the drive, step the heads, and, you know, why not just clip the analog input on the scope to the flux read output? Maybe I can recreate what IMD does and identify when a track is directly under the head, and then we could have a hardware drive alignment tool, you know? So we can do something like that. Deck Talk is now on, sorry. So this is, it's going to be a very big project, very long project, and I expect massive...
External power on.
Don't expect massive progress or any kind of timetable on when this may or may not happen, and I'm not guaranteeing it'll finish or that I'll come back to it. I just want to start some investigations. So that is what we are doing today. All right. Let me catch up on chat here a little bit. Let's see, you're working on making the Sony floppy drive tester. That's super cool. So this isn't really about floppy drive testing. I'll state also the...
Tier 100 start of line. End of line.
I'll get to those in just a second. I'll state also the ultimate goal here is actually to design a case that can hold an 8-inch drive and then several 5 1/4-inch drives on their side, and then a stack of 3.5-inch drives all at once that have the floppy interposer in it, and then it is not necessarily a standalone floppy disk imaging and maintenance and diagnostics drive enclosure, but it's about as good as you can get. You could probably make it standalone by chucking a Raspberry Pi in there and interface with the grease weasels, but that's an ancillary goal. So the ultimate goal is to create a consolidated floppy drive and disk archival solution here. So again, long way off. We have to start small, just look at a drive, look at signals, see what we can do from there. So never SCSI. SCSI is completely different than floppy. SCSI it's not even in the same problem. It's like, why not try and also, you know, do USB flash drives? Completely different. So, okay. Nothing as long as a MakerBot. The CM153 cloning was longer than the MakerBot. Just throw that out there. All right. 100% has to play a little jingle in the head stepper when you power it on. It could, but it might also just have a piezo on there, because one of the things that would be really cool is to have a clean routine. So let's say you get your cleaning disk, you put it in the drive. There's going to be an LCM 1602 type panel on it, all right? Rotary knob button, okay? You select clean, you select drive, you press start, and then it'll just automatically cycle through it, and then when it's done, it can play a little chime through the piezo. So it's just, there's options. CM153 clone is built by others, used with their drives. Yes, that is super duper cool. I will say this. This is going to be a big project. It's going to be, by the end of it, a very expensive project. The coffee machine is functional. I just already have coffee. When I come to the office with coffee, I don't want to make more coffee because, I mean, I have coffee. I'll say this. It's going to be a big, expensive project, and I feel like this is the kind of thing that other people might want, and it's going to be too expensive for me to just sell, and I think it would be really expensive for other people to reproduce. So I'm going to say this, but I am, again, not making any kind of commitments. I'm not against the idea if this really works out, and after it is fully finished, complete, designed, tested, trying to do something like a Kickstarter to make like 100 of them. So I'm not against that concept, but we'll see how it goes. All right. So, yes. All right. Let me cover how awesome you guys are here. Okay. So first off, Bezo1, thank you for the tier 1 sub there and for 18 months. I appreciate that. Mighty Halo, thank you for the tier 1 sub and ending out base 10 there. Thank you for the 10 months of tier 1. Tier 1. And then Chloe, thank you for the 100 bits there. So, okay. I think I've established the goals here for today. So, like I mentioned, we're just gonna poke around. That's all I'm setting the bar for today, is to just kind of get a feel for how this project is going to go, okay? We do not have any distinct goals today other than little things like I would like to manually step ahead. I would like to read a track select or a drive select line, things like that, okay? Should big emoji count as bits as well? I mean, here's the thing. The deck talk only reads at 100 bits, and I have to draw a line somewhere between 1 bit and what number I will have the deck talk, you know, acknowledge, or I myself will acknowledge, and it's difficult to say, so I just 100. That's the minimum where something, I don't know. Additionally, I do see something, so I don't know. They are bits, yes, but you know, you gotta figure out what is worth acknowledging. Just take my 30 cents. Sorry. Yeah, there's a line where it's dance monkey versus, you know, something that's actually, you know, meant to be positive. So, all right. Glad he hasn't said at least that high. All right. So I was working on, before the stream started, I was working on cleaning up the space back here because this is one of the pods for the 16500C here. And let me try and position this camera in such a way that you can maybe kind of see the space we're working with. It's really, really difficult. I'm intentionally, this is an awful angle, okay? Stuff has wires, get over it. This only reaches this far, and in perspective of the other workbench, it actually can't touch the other workbench unless it's directly in front of the keyboard. So we cannot do any logic analysis over there. Now, I was contemplating trying to move this over there, but then what's the point? Why do I even have the electronics bench? Okay, so we're gonna try and work over here today somewhat, but we'll figure out what the balance is here as we move along. So, yeah. He ran out of data? No, this is just the usual stream. You have an ESD. Uh, really quick, one of the pod clips, here we go, fell off. Let me just get that clipped back in. All right, also the video capture for the 16500C was disconnected at some point, so I'm gonna have to try and crawl back in between the two benches. Oh my gosh. That's right, really, it's gonna be really bad. Pre-roll ads right into an ad break. What? That shouldn't be possible. Hold on. That should be completely impossible. Unless Twitch changed their ad settings. Pre-roll ads for incoming viewers is fully disabled, so I don't know why you would have pre-roll ads. If you are, it is not my doing. I have heard that it can be related to having a ad blocker installed. I'll just say that. That's the full extent of my knowledge on that. All right. Kind of good enough here. I got an assortment of capacitor legs that I would like to preserve here. So give me one moment. Actually, I can use a magnet to pick those up because they're steel on a tablet, so Twitch is off broken. All right. Yeah, I don't know. That's what just happened. So a pre-roll ad is you click the stream to start watching it, okay, from another page. And then as soon as the stream starts, you see ads, all right? That should be disabled. I just checked my settings. That should be disabled. I've tried very hard to make sure that does not happen because, yeah, that sucks. But the only way to make that happen is to run other ads. So, that premium so you just watch on YouTube, that works too. Coworker shorted 24 volt PSU into a PC case. Display started flashing. Yeah. I almost kind of sort of did that today. It might have been more HDMI back voltage feeding. I'm not really sure. It was weird. I was trying to test out my next dock, the little HDMI input thing I've got. I had an idea where I thought it would be cool if I could use my VGA to HDMI adapter that is 5 volt powered. So what I did is I plugged it into the next dock's USB port and I enabled the device charging, which powered the VGA to HDMI converter through the next dock. So theoretically, it should have been able to do VGA input at that point. All right, I had it connected to the mini HDMI input on the next dock, and then I plugged a VGA cable between the test bench and the HDMI VGA adapter on the next dock, and the display plugged into the GoTech on the test bench turned on when there was no other power going to the system. So the test bench was somehow being powered through VGA through the VGA to HDMI adapter from the next dock. No idea how. The next dock survived. I connected everything to it again just to verify it. It's fine. But yeah, that was weird. So hopefully you get something YouTube Premium. I should, when it comes to watching videos with ads, YouTube Premium views are worth about 3 times as much as regular viewers. I don't know how it works with live, but I imagine it's probably, you know, oh my gosh, brain activate, comparable. Eesh. First power over HDMI, now power over VGA. Yeah. VGA also has 5 volt pin. Yeah, but I wouldn't have expected it to, like, send power over that. I don't know. It's weird. Anyway, all right. I think we're good to go here. I'll show this because you might notice here I have a mouse and a keyboard. These are actually the mouse and keyboard for the workstation, and I actually have that right here for a change. So in theory, I can actually do stuff over here right now. And I did that, and it's actually making me think I should get a wireless mouse and keyboard because that would be really convenient. I have a 16:9 1080p monitor over here because we were doing server stuff, and it just made sense to put that in. I should have done this a long time ago. Anyway, I also moved this over here, which was literally only purchased for this kind of use case in mind. I can plug a microcontroller development board into this, and if I do something dumb and short USB and 5 volts, or power and 5 volts, or whatever, this is isolated. That's the whole goal of this thing. So I should, in theory, be safe as far as like monkeying with electronics stuff and, you know, USB and programming and things. So if we do microcontroller development, we're going to do that over here with the isolated USB hub. So yes, okay. Do you need numpad? I don't need it. Generally, I'm going with no numpad for desk space conservation, especially, you know, at the office where things are maybe slightly more cozy, let's say. Yeah. Can power Raspberry Pi with HDMI with an injector, but you have to add a diode because it'll fry some displays. Oh my gosh. On that, actually, I have the Raspberry Pi connected through not the network adapter here for the rest of the office now. If you weren't here when I mentioned that a while ago, the streaming computer is now the only computer that uses the LTE data. So that's it. Only that. Every other device in the office now uses sponge Wi-Fi, and doing that split so far has been working out better. There was a thing I was going with. Oh yeah, I had speculated that the Raspberry Pi's internal Wi-Fi was not that good, but it turns out that the Cox Wi-Fi access point just sucks. I could, now that it's connected 24/7, I can go back through on the Unify router and check the service stability, and it's terrible. It's actually horrible. So yeah, it was always going to fail trying to use that for streaming. So yeah. Okay, wireless keyboard. So I am actually very familiar with that DZAC. I have seen the Model M version of that in person. Fun fact, the numpad magnetically, it doesn't attach to the keyboard, but it magnetically like snugs up against it. So if you buy both of those, yeah, you can do that. So, sorry, tablet PCO is gonna send you appears to be dead. Oh, that's fine. I appreciate it though. Okay, I think we're ready. I'm just trying to plan out what exactly we're going to do here. So let's try and get the 16500C working first, actually. So get this on. Let's do video capture on this. So I think the VGA cable for that is still chilling over there. I might see it. I'm gonna, you know what? I'm gonna be smart for a change, rather than like lean over a bunch of stuff. I'm gonna use that grabber thing I accidentally had out yesterday. So is this the VGA cable or is this a network cable? That is VGA. Actually, that's connected to something. What? Wait a minute. Do I have the 16500C connected right now? That would be super convenient. Let's see. This is going to that, which goes to. What now? To here. Okay, so I can connect this to this thing, and then to this. Boop. Okay, in theory, now if I press this, there's a downside to this setup, unfortunately. You mean PS2 controller power up cell test failed? Yeah, that tracks. Okay. Need it for your living room now? See, ordered a keyboard case, color e-ink tablet. Ooh. Arrives a complete second tablet, but no case. Ah, darn. Shucks, I hate it when that happens. Hold on. Why am I, you know what? I'm just gonna do the thing. I'm gonna reboot the capture stack, because it seems like every time I try and do VGA capture now, it doesn't work. Then I reboot the capture stack, then it works. Okay. Wi-Fi is fine, the AP is 30 meters away. Interesting. Does VGA and HDMI adapter work with Japanese computers? I don't own any Japanese computers, so I have no idea. Plus, it's just some garbage one. I would not recommend it. PC Master Race got 2 monitors. The price of one. What's that about? Okay. That was audio coming from the capture stack for some reason. Okay, matrix local goes to all the stuff. About this. Hold on, I'm gonna try something different here. I got the DVI connector down here that I can run VGA into, and I'm going to set up that VGA port for the 16500C, because if you remember, the 16500C outputs like a real weird VGA resolution. I don't remember what it was, unfortunately, so this is going to kind of suck to set up, but I think this will be an easier way of doing this. A little bit more likely to work. Unplug. Oh, that's right. I am dumb. Okay, back to the other method. I forgot I have a DVI extender on the DVI port that can accept VGA input through the DVI connector, except I plugged a DVI-D extender cable into it. So it doesn't do VGA. It's very annoying. All right. That looks like that's plugged in. Okay, so as long as the VGA stuff is connected on the 16500C, this should be working. Why is it not? We might need to mess with some stuff. One moment. Okay. Let's see. Oh, all right. I'm going to try to figure out, just for giggles. Okay, so it's not working. So let me explain what it is I'm trying to do. So this is my logic analysis mainframe. Excuse me here. So it's a touch screen. It's fancy pants. Look at it as like an oscilloscope. There's logic, state, timing, doodads. It's crazy. Okay. We can do VGA capture of this, so you guys can actually see this. So it would be really nice to be able to do that. And I've set that up, but I need to get it working again, and it's not for some reason. So that's the goal here, is to make that work. So, all right. But I need to, oh, you know what? I cannot configure the VGA capture stuff from the streaming computer anymore because it's not on the local network. So, this is going to get real weird. Oh, actually, this sucks. Hold on. Wait a minute. This might take too much work to do. Maybe we just start testing and I just point the camera up every now and then when something interesting happens. All right. How many minutes are we into the title? Are we into the title product? 10, 30 minutes? Or yet to start? Kind of yet to start. The SSX, oh my gosh, the X session is garbage. It's useless. You can't see measurements because it uses frame buffer hack drawing to do that. It doesn't matter. So just ignore the fact that it even has X. It's good for configuring it. That's it. So, all right, we're just going to get started. I'll just point the screen up when something interesting happens. Because here's the problem. I can configure the complicated settings through the capture device, but then I can't see it, and it's like a whole thing. So, all right. We're just going to get immediately started. All right, so the first goal here is going to just be measuring, not with a microcontroller, measuring floppy disk signals with the logic analysis mainframe as they happen. So let me explain the setup here. We have the tandem drive connected to the end of a floppy cable. This cable is then connected into a splitter cable. One end of the splitter is going to go into the grease weasel here. The other end of the splitter goes into this breadboard, and then I can connect to the signals on here. Now, in theory, I could have only connected one side of the breadboard because I believe the other side is all ground, but I just wanted this to mount a little more securely, so that's how we're rolling. So, first played around with floppy drive comms, used bits of wire shoved into the floppy cable in the fancy logic analyzer. Yeah, this is going above and beyond, for sure. I very much get that. I think maybe I don't need a longer cable because it can't just go over. Okay. Boop. Okay. I'm going to turn off the grease weasel because I can do that. And there we are. And I'm going to bring the 900 watt floppy power supply over here. The world's best floppy drive power supply. And we're going to go ahead and poke around with some stuff. It is, in fact, a 16500C. All right. Now, here's a goal for the floppy enclosure box that I mentioned, as far as, like, there's, why would I want to do that instead of just using a PC case? Here's an example. You're going to have, like, say, a tandem drive that's in there, that's your go-to 40-track drive or whatever, all right? It sucks to plug and unplug this power cable connector, okay? It's actually awful. What I want to do is I want to have modular power cables. So you'll plug this in here, but then there'll be a power back plane, and then there'll just be a Molex MiniFit Junior type connector back there. You just unplug that, and then you can lift this out, leave that little pigtail connected while you service the drive or whatever. So, yeah, that's an example of one of the things that I would really like to be able to do. So, okay, step one, power drive. Boom. Drive is plugged in upside down. Is it that? It is not that. It's this. There we are. This shouldn't actually matter. All right. Turn that on. We're good. Okay. Turn on the drive interface. All right. Is it 900 watt in the right rails? In this case, yes. Okay. The 16500C, remember the scope card doing that? Ended up picking scope card, works over X. Ooh, that's nice. I didn't know that. It doesn't matter because I'm just going to keep using this thing. That's definitely good to know in case I ever do end up with a later one. All right. Let's do GW clean -- drive A. All right. And let's Let's make this the correct parameter. Boom. This is moving. All right. That's what we want. So that works. So now we can try and measure some things. So let me do something here first. Floppy interface pin out. All right, panic over here now. That's all the answers, yeah. All right, let's pick one of these to be our go-to for now. That's an adapter. We don't want that. 5 1/4. I mean, they're both the same. Doesn't really matter. So just to, oh, that's one of them evil ones. We don't want that. See, it should be all ground on one side, like I mentioned. So 8-inch Shugart, that's a little more than we want. That's pretty close. Yeah, you know what? Hold on. Image, a new tab. Copy image. GIMP. Paste. Image, transform. Rotate clockwise. You can also just hold shift and rotate like that, but I wanted it to actually be correct. Okay. All right. Sneeze averted. So, pin 1. Oh, that's almost convenient. All right. So we're going to have the data pins on the outside here. So these are the signal pins, thankfully. So I want to look for step. So I want to check that one first. To make this easier, we're going to just start with the scope because that's going to be a whole lot easier to do our initial tests with. Plus, it'll give us voltage readings. I don't know if the logic analyzer portion does. Also, the logic analysis part is a lot harder to use. Top of the box is a bit cut off. Little bug in the chat overlay. What? No, it's not. It's fine. Okay. The top of the box is not cut off. That's just how it works. You can't have the lines don't start from the top. They start from the bottom. So you're going to have lines cut at the top. All right. I'm going to go up to, oh, this sucks. This is going to be miserable. All right, we're going to go to the oscilloscope card here. We're going to use yellow since it's...
Ironborn subbed as tier 1 and says, end of line.
Lady Ironborn, thank you for the tier 1 sub. Oh my gosh, 33 months. I think that means double thumbs up. Oh yeah, thank you so much there. Just never paid attention, so I thought that was... no. Okay, so we can actually get rid of this. Boop, done. Okay, so we're going to have only C1 here. All right. So it's like all ground on the other side, I believe. So I'll just grab any one of those. And then how many down is it? Okay, yeah, I kind of wish there were numbers here. One moment. So we're just going to make this a little easier to read. Well, I say I want numbers there,
but... 3000 SUP as tier 1 and says 07. End of line.
Super Scott 3000, thank you for the tier 1 sub there. And for 12 months. I appreciate that. Again, the box that I'm currently visible in is hardware. It can't be moved. I mean, it can be, but it can't be moved easily. It's the same every time I restart all of the capture hardware. Okay, I'm just going to image, canvas size, width. I'll just slide it over, resize. Okay, go here. Boom. Actually, just new layer. That way I know it's the correct size since it doesn't give me any grief. All right. Make sure it's black. Then the font size is, yeah, going to be hilariously wrong because this image is tiny. All right. 2, 3, 4. So, Norsab, that's correct, but I'm going to be counting down from the connector, and it would be nice if it just matches what I'm going to actually see here. Five, 6, 7, 8, 9. Okay, too small. Okay, that looks like it'll be just right. 10, 11, 12, 13, 14, 15, 16, 17. Okay, perfect. I'm gonna make this 10.3. 10.15. Okay. All right. So I'll count down 10 to get to the stepper. Okay. So all I want to do is just measure this whenever the drive steps. So that's the goal here. If I was really smart, I would have used the numbers on the breadboard to indicate anything. Here, maybe I should just do that there. 50 is pin 1. Okay, so that means I can just drop down to 40 right there. Okay. Step is... Why does that not seem right? That seems farther down. Well, maybe it's okay. I don't know. Let's find out. Okay. Clip and clip. All right. Go up here. Run repetitive. And then I'm gonna run GW clean again. It says no thank you. Why? Huh. Just to double check, let me disconnect. The pin 1, I'm assuming, is the red stripe. Well, Grease Weasel's being a Grease Weasel, so it decided it's not going to work anymore. Okay, it does this a lot for some reason. I don't get it. When it did it, fatal error. You know, it might be the whole tracks, whatever, tracks C equal 0 through 39 nonsense, invalid argument. On a an external USB floppy doesn't help, but you should be able to, just in theory. Oh, the red line, the red stripe was on my side. So, all right, I'm just going to try this. Turning off drive, turning off grease weasel, turning on drive, turning on grease weasel. Oh, now it works. And because I didn't have the scope connected, of course we didn't see anything. That's something I would really like to solve. And now it's messed up again. Off, on. There we go. And I'm seeing nothing there. Why? Because it disconnected. Oh my gosh. Okay. One more time. And it failed me. Off, on. Why is it not changing? This might be too slow. So... Oh, that's interesting. Yeah, I'm going to guess that's too much. Let's go 1 volt per div. Offset. I'll just bring it down, center it, whatever. Okay. Let's set up a trigger. All right, auto trig. Okay, so let's just stop. Single. Wait, did it? Auto triggered. Okay, let's raise the trigger level. Why is it triggering? What voltages I think it's at now? Okay, I kind of hate this interface. Auto measure. Every time I try and use this thing, it's always a nightmare. Okay.
Magicotech gave a tier 1 gift sub to 99 Tango. End of line.
Majenko, thank you for the gifted sub.
Tatorskin says CHER 100 question. What kind of clips would you use if you were trying to use the logic analyzer with PLCC chips that are in dash dot sockets? I have a mess of S hooks, but I'm having trouble getting them to stay attached dot. End of line.
I don't think there are clips for that. I think you need to get a socket adapter to break the pins out. The red stripe was towards the camera, yes. It's possible I'm on the ground side. I don't know. Right now, it doesn't matter. We have the stupid thing being dumb. Just hold on. You know what? Let me sanity check something here real quick. I counted from the end towards myself. Actually, I didn't even count. The black squares on here that there's no way you could see are markings for every 5. I started at 50 and went in 2, so it was 50, 45, 40, so I put it there because it was on pin 10. So I went down like that. But what I want to check is make sure this side isn't ground. Right? It's the other side that's ground. Yeah, the other side is ground. So, pin 1, I went down 10. That's correct. So I had it wired correctly. One, two, three, four, five, 6, 7, 8, 9, 10. There. Okay. Okay, it is possible that was the 11th pin in that was write data, which would be super weird. Okay, I think I was wrong in that regard. The counting part, I got off. I had it off by 0, or off by 1 error. Fence post error. Anyway, this thing's still stupid. Hold on. Turning on floppy drive, all right. On, off, grease weasel, because it's super dumb. Clean.
Tier 1 for 12 months and says, end of line.
Still not seeing steps. All right. Regalks? I'm not sure how you would want that pronounced, but thank you for the tier 1 sub there for the first time ever. All right. Outer output pins need pull-up resistors. There are pull-up resistors on the drive because there is a drive connected. We're snooping. We're not, the circuit is complete. I mean, it's stepping the drive. We're just trying to, measure the voltage. But I'm not seeing anything. 200 nanoseconds per div? Okay, I think I found our problem. Okay, here's 20 microseconds. And the stupid grease weasel. Okay, does anybody have any idea why it does this? Is it how do I... Hold on. It's going to drive me insane. I have to fix this. This is one of the reasons why I want the hardware clean. Grease weasel really drives me nuts sometimes. Okay, GW, raw, 40. Actually, just look at raw. I'm just trying to probe floppy stuff in general, but right now I'm looking at the head seek pin. Okay, it is tracks. I don't want it to be GW reset. I would really like to know why this doesn't work. Because that doesn't make sense to me. This should work. Does clean not support this? GW clean dash H. Sills. It has a separate Sills number? Seriously? Now GW reset might work. Hold on. Okay. Hey, it's repeatable. Okay, we're still not getting the signal, though. All right. So that was the problem. It was the Sills command. I don't know if I'll be able to remember that. That's going to drive me nuts. All right. I have no idea. I'm not triggering right now. Right now I'm just like free running. But in general, yes, trigs are always bad on this thing. This thing sucks as an oscilloscope. It's actually terrible. I might, maybe we shortcut. Saw a brief blip of a signal. Yeah, I'm sure it was some random gamma ray or whatever that just hit it. Maybe? Okay, hold on. Trigger, display, no. Auto measure. Okay, what are we getting? Edge required for measurement, not found. You know what? I don't like you. Boom. Okay, fine. Trigger, level, I don't know. There, run. It thinks it finds something because it's stupid. Edge, positive, auto trig, I don't know. Source, channel. Why does it trigger instantly every single time? I don't know. I don't think auto trig is it. Waiting for trigger? Wait a minute. Is it that stupid? Okay. It's never triggering. Think all control signals are active low? Oh, that's super annoying. See, that's the kind of thing that I want to know. What kind of dumbness awaits? Hand me one of them ideas, though. Hold on. Seriously? Okay, well, now I'm just annoyed. That should be capturing video, but it is not. Okay, why is this not working? Now there's no excuse. Ugh, stupid capture hardware always being dumb. Okay, hold on. Is it getting video input? It's not even getting input. What? How? Oh, because I'm super stupid. It's going to be one of those days, isn't it? Glad I set the really bar low. The really bar low. Yep, it's definitely one of those days. Oh my gosh. Okay, it's still not working. Oh my gosh, I still have it plugged into the wrong thing. I want to cry. Yep, no, it's this. That's correct. Okay, you're getting input. It's not getting input. Why is it not getting input? This is not the cable I thought it was. No wonder we haven't been getting any VGA capture. Oh my gosh, are you kidding me? No way. Come on. Oh, I want to scream. Hey, look at that. Oh. Okay. Well, at least we figured that out. Oh. All right, one moment. I'll make it fit. Okay, so we have HP 6500C capture now. Excellent. Okay, that's not what I want to capture, though. I want to capture this tech. All right. All right, we're going to cheat, and we're going to use a scope that wasn't designed by people who have PhDs for people who have PhDs. And this one will just work. All right. Actually, I think the 16500C is really meant for automation testing only. I don't think it's really meant to have active input. So, yeah, I think I think this is going to work a lot better. Okay. All right. So I want to set our, you know what? Auto set. Just do my homework for me. Okay. There's a signal. And now the drive's not working. Okay. Now this sucks because I need a laptop. Hold on. I need something that can control the extrons desperately. Or else today is going to be miserable. Ugh. Yeah, Phil, you have it dead on. Yes, you're correct. That is what its suits are. But the lack of any buttons also shows that you're really not meant to use it directly. It is meant to be computer controlled. Maybe perhaps by some kind of, I don't know, HP Series 200 technical computer, maybe? I don't know. You have the one without the front panel? That's what mine is. So the C is knob only. Actually, I think all the 16500s are knob only, but they are touchscreen. So there's that, and it's the super ridiculously cool. I think it's ultrasonic. So, all right, go ahead and restore my session. That might bring back pinned tabs with Extron controls. It did. Beautiful. Okay, which means I can do boop. This. Oh, that's so much better. Okay. It's infrared. Maybe. I don't know. I haven't taken that part out. So, anyway, it doesn't matter because it's meant to be controlled by that thing. That's where it's at home. Anyway, so for some reason the Grease Weasel decided to lose its mind again. So reset there. Okay. Back to capture. We're almost seeing signals. They're like pulsing all over. Why didn't you get a regular scope? I got perfectly fine scopes. Yeah. Yeah, I just hooked up my totally normal, you know, CRT scope from, what was it, like 1985? Can't believe you have a cursed Grease Weasel? Yeah, definitely. Of anyone out there who would have one, it definitely wouldn't be me. Yep. Anyway, yeah, we're working with this one. But why? Yeah, maybe we need to bring in the time. I'm trying to, oh, seconds per div. Here we go. Clickety click click. Okay. That's a little too long, but you know what? That could be interesting. Okay, or not. Oh, I've spun it the wrong way. Well, maybe now that there's like triggerable doodads. Okay. What? Aha. Okay, it is negative. Oh, that's annoying. Okay. Well, there we go. We've characterized the first signal. It's exactly one of those kinds of things that I was afraid of. Okay. So, question now. I'm gonna get a little cocky here. Try and use something that I probably shouldn't. And that some is the probes, by the way. It's very modern. It's dark mode on, yeah. Okay. Plug that in there, and this in here. Okay. What I want to know is the signal here always high, or is it going low, like negative voltage? So we're going to do a voltage measurement here across those pins, and 1.1 volts. What? Of all of the voltages I could have seen or predicted, that's not one of the ones that I would have predicted. Is that going... What? 1.1? Are we going negative or... Man. Let's see if this thing's fast enough to catch those pulses. Okay, I don't think it'll tell me. The ground is ground coming from the same floppy signal. I can clip to, like, chassis ground on the drive. I don't think it liked that. Oh, also disconnected from the pin. Yeah, so chassis ground on the drive is the same. Huh. Resistor pack on the drive's not pulling up every signal sum or... So, all right, you're saying I should get a pull-up resistor to measure this signal. Okay. All right, I guess. Now this is a lot more complicated then. It is missing the terminator plug, if that's what you're talking about. So, yeah, this one does not have that. One moment. Dang it. This other drive's also missing a terminator. If only I could get like 5 more of these that maybe have the terminators, then, you know, I could possibly have this functional the way that it should be. Why does it work in a PC then? Or with the grease weasel? That's weird. The disk ferret. I am not familiar with that project. Is this from the Catweasel era of hardware? Okay, so pages do work. Interesting. I never heard of this before. That's super cool, Phil. Huh. Well, awesome. That's really cool. Yeah, making an FPGA, that's going to make it a lot more expensive. Does it do onboard processing or something? What made you go that route? Because I'm just curious. Yeah, that's really cool. Okay. Okay, so we could potentially look up what the resistor pack on the drive would need. And then we could possibly put resistors just loose individually in there. It's so stupid. 100 megahertz clock rates to Winchester RLL drives. Ah, okay, that makes sense. Mm. 1K is fine? Okay. They just go directly across, right? Like, it's just, there's no weird thing. It's just straight over. All right, I'm going to grab some water here. Yeah, my goal is not flux imaging of any kind. Like I did say earlier, I might try and read the signal to try and get an idea of signal intensity for alignment. But that would be the limit. So I think a hardware alignment tool would be kind of cool. All right. I'll jam some 1Ks in there. We'll see what happens. Practice those never implemented. It has GPIOs. It's not sugar drives like Apple II, Masumi, QuickDisk, Nintendo. That's cool. Live tools your current project. Ah. Aren't actually termination pull-up resistors. Yeah, yeah. All right. Let me grab some 1Ks here. Oh, wow, there's not as many in there as I'd thought. I bet like almost all of these are in breadboards. Drat. Okay. That might be like just exactly enough. Huh. All right, I hope you like this drive. You're about to deplete my stock of 1Ks. Come on, your stool. All right. Fairness, you have a CE disk. Alignment isn't terribly hard. You have a grease wheel, send the control signals. I'm not sure what you mean by CE disk. It's like a reference disk of some kind. So I've used IMD to calibrate drives before, but what I would really like is, well, one of the goals I would have with this project, let's phrase it that way, is I don't need it, but I would like to be able to do it all in hardware. You know what would make this easier, and I'm gonna grab my needle nose pliers that are hopefully in here, and I'll jam these in there with that. Of course they're not. Okay, are they just... And in here, they're the one pair that are missing from the set. They didn't end up in the drawer, did they? There they are. Yoink. Okay. Cat eye. Oh. Oh, that would be complicated to make. Yeah, for sure. I think in theory you could do something. No, I was going to say, no, you couldn't do that with a grease weasel either, because that's analog, isn't it? I bet the yeah, the tracks probably wobble. That would be a nightmare to make. Note to self, buy DIP 14 resistor packs. You know what I could be doing is measuring the voltage here, and then once it goes high, I could just stop trucking them on there. 150? Well, 1K is probably going to be fine. Okay, we're at 1.1. Pulse don't need to be that strong. Let's use really long cables. Yeah. Disc manuals. They have a picture of the cat eye signal. Looks like the do decent job aligning discs. Bulk erasing, formatting only one track with the GW. Using good one. Yeah, so that's essentially what I've done. I have a bulk demagnetizer that I use for stuff like that. That was especially critical when I started messing with that HP thing, because the lift stuff is just nuts. It's almost like these legged resistors aren't meant to go into the flat lead socket. You know what would be smart? If I wasn't doing this with the stuff powered. Understand what's going on? Didn't we see in the analyzer the signal is already pulled high? So what I did is I measured the voltage of the high signal. It was only 1.1 volts. So it was a little low for a logic voltage. So I'm hoping that this pulls it high and it becomes like 5, and then it drops to 0 when the logic is activated. It's more that the 1.1 volts didn't make a lot of sense. So I'm hoping adding the termination resistor, pull-up resistors here, and try and call it correct, will bring it up to 5 volts. Or maybe 12, I don't know, probably 5. I'm only doing it in the drive because I don't want to have to. I mean, okay, I guess I could have. I didn't even think about that. This could have been a lot easier. Dang it. Oh my gosh, stupid brain. I was like, oh, I don't want to have to try and connect one of the amp mate and lock connectors to the breadboard. That would suck. Oh gosh, and SATA would be even worse. And right as I was about to say that out loud, I remembered that the Burge floppy connector is just 100 mil pitch IDC compatible. So I could have just put a header right on the board. Been done. Problem solved. Idiot. Because then I could have done this all on the breadboard and had the pull-ups on there, and it would have been a lot easier. Just go boop, 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 in a nice open area instead of cramming them in a socket that they're not meant to go into. But, you know, we're in it now. We're doing it. Oh, this is awful. And your next order. I can't click that right now. Okay, we got 2 extra mirrored in Discord. Okay, well, I just like, that computer is not logged in to Twitch or Discord, and the only other, there's nothing that can click that right now. That's what I'm saying. I can't click anything right now. The legs keep bending as I'm trying to push them in. And then I'm not even sure that I'm making connection because there's like glue and crud on the legs. And I didn't clean them and just like, this may not work. Ah! Okay. That's all good. Turn it on. 5 volts. There we go. All right. That's what we want to see. Okay. All right. Let's do this. Oh, wait. I was going to say, let me just click my way back to the HP 16500, but I can't. All right, let's do this differently then. Let's go. Hate touchscreens. Here. Okay. So, no, that's wrong. This. Okay. So, this thing, all right. Power on Grease Weasel. Okay, hold on. No, I got to go back. One moment. This. Boom. Okay, that works. That does, in fact, work. Scope. What do you see? Ooh, it's beautiful! Okay. Volts. Down. Right? Okay, hold on. Is that 5? Oh, now we're talking. Yeah! Okay. Let's pretend this is 0. Okay, so it goes high and drops down. Okay. Very disappointed by the lack of yellow case dip resistor packs on DigiKey. Okay, I'm much happier now. All right. Whew. You know what? I probably could have just plugged a different floppy drive in, too, now I think about it. Oh, well. Ugh. Water is very, very good. Okay, so minor victory there, all right? Okay, to give you an idea of one of the features that I could see theoretically being useful here, all right, is the case that I want to make that all of the drives that go in there will be connected through the floppy interposer board. I think it could be cool to have the hardware interposed board that will control the signals be able to be plugged into a computer and then have it automatically double step the drive. So let's say you plug a 1.2 meg 80 track drive into a 5150. You go into the settings, you set it to auto double step, then the 5150 will automatically step to the correct drive positions. Just that's the kind of thing that I think could be weird and useful to just have in this hardware. It's not something that, you know, you'd probably realistically ever need, but it would be there and it would totally work. But we need to be able to check things like this to be able to see and do that. Okay. I would like to now learn how to trigger on this signal with the 16500C so that we can start to learn how to do that. Oh, I'm sorry. So let's go from that to that. Okay. And we're gonna make this slightly more complicated now. We have all of this working and functional, blah, blah, blah. I am going to turn off, you know what, just pretend that you see me switching the 16500C off and on, all right? Because I would like the keyboard that's plugged into it to work, and it needs to reboot to do that for no particular reason. Okay, get the tech disconnected. The tech did a very good job here. Okay, I'm going to shut that off now. And let's start by just connecting the analog signal, just since we know what that looks like, and then we will switch over to the pod in a bit and actually do logic. But I want to try and work with this a little bit here first. All right, it's booting up. Okay, there we go. Now, you know, in theory, I could actually just work over here. Wait, where's my mouse? Oh, really? That didn't show up? Dang it. Let me make sure that it's properly plugged in. Feels like it. All right, try one more time. I don't know if it's this keyboard or the combination of the keyboard and this hardware, but it does not like working with the PS2 mouse and keyboard. It's very cranky about it all the time. Yeah, we're down to 3401 here for a moment. All right. All right, please work. Aha, that's a cursor. Beautiful. Okay, so system, oscilloscope. See, we don't need no fancy Rigol. Okay, we see that that trace went high. Oh, perfect. Okay, let's get in here. Let's go to C2, delete, 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 delete. Perfect, done. Okay, so channel trigger. Okay, so we're gonna trigger on a -1 volt signal. Oh, not negative. No, let's trigger on 1 volt. Okay. Slope negative. All right. Run. Why is that triggering instantly? Hold on. Channel. Let's go 1 volt per div. Offset 0. I don't know if I have my probe set correctly. This one was set to 1x. Okay, that might be part of it. This is set to 10x. Okay. Auto trig is on. Off. Okay. Okay, but it's still not triggering. All right, trigger. Slope. What do you mean level 36 volts? Hold on. Channel, probe. 1. 1 to 1. Oh my gosh. Need to get proper probe 6500C. All I've gotten are these dinky Chinese 1 meter probes aren't long enough. Oh my gosh, that's what I have too. They're terrible. I think I managed to find some that were like 1.5 or something, but that's as good as it's got. It's awful. This thing drives me nuts. Why is 0 way up there? Offset 1? Offset -1? Why is it up there? Yeah, Phil, I do not blame you. Yeah. Especially if you can remote into it and have the like stuff actually work. Yeah, I can see that. I cannot reliably do video capture from mine, but yeah, it's or do mouse and keyboard. Also, it's too much fun to be able to show off the touchscreen. Wait, why is one of my power supplies on? Is that the 5 volt per div? All right. I don't know why it went to 4. Did I type 4? VDiv limit. Weird. I'm going to set the probe to 10x. I'm going to set the thing here to 10. Set this to 5. Set this to 0, I guess. I don't know. Run. Okay. I swear it's like, unless that's it right there. Maybe that's it. Let's go with 5 millisecond per div. Okay, I think those are head steps. I think it is working. I think the resolution's really terrible for some reason. Offset -0. Yeah, I think the steps are showing up. Okay, so if I run it again, we can start to... I don't know if you guys can see it with this resolution. Turn on join the dots. I thought it was on, but you know what? You might be right. Connect dots. Okay, here we go. So run it again. There we go. Okay, so we are seeing it. Slope, negative, level. 2 volt. Okay. All right, we're finally getting somewhere. This is the one time I'm just going to reach over and zoom. Oh, finally. Okay. Ugh. Blah. I don't remember this resolution being so terrible, but all right. That's fine. Whatever. I don't care that much. All right. There we go. You can just tell it's first generation DSO. Yeah. That's one of the things that makes it so cool, though. That and then VGA capture is really nice. I'm sure there's modern ones that do like HDMI out or some nonsense, but you know, VGA capture. For the record, Phil, I don't know what your 16700 has. So this one, the internal monitor is just RGB HV connected to the internal Trinitron. So I put a VGA splitter internally and added my own adapter inside that connects that to the VGA splitter. So I have actual VGA out on here, but it's only the RGB HV, and then I run this through a Extron presentation scaler that allows me to capture this at the correct resolution because it's so weird. But yeah, that's how I'm doing this. This one does not just have VGA out. I modded it. So glad they fixed this interface on the Infinium and Infinivision. So this is the only one thing like this I have used. I do have the 1650. I don't know, it's a dedicated logic analyzer that's a monochrome CRT that has an interface very similar to this. Yours doesn't have a monitor, has VGA out. That's hilarious. So yeah, mine doesn't have VGA out, but it does have a monitor. Oh, that's amazing. So yeah, I had to mod mine to do this. So that's funny. It probably didn't even seem slightly odd to you that I was using it this way. Okay, that also explains why you turned yours around. Yeah, why have it facing you at all in that case? If it doesn't even have a monitor. But all right, there we go. We got the analog side working here. I'm very happy with that now. Okay. Let's let's make it more complicated. I'm going to stick pod 1 probe 0 on this same exact signal, and we're going to try and simultaneously measure it on both. So we're about to actually flex the power of the 16500, or the analysis mainframe series here. So yeah, I frankly have no idea how you're supposed to use the 16500 except for computer controlled. Like it doesn't make any sense having all the ports where they are and how long the cables and stuff are. It's kind of awful to use. I'm sure if I had like the original HP probes, actually, I bought you'll notice I have 4 channels in this. I bought a second oscilloscope card for mine, and it was supposed to come with probes. And I was more mad when it showed up without the probes than if it had showed up without the second oscilloscope card.
100. Let's make this more complicated is obviously the billing for the stream. End of line.
Oh, thank you for the 100 bits. So you used to make scope cards for oscilloscopes? Oh yeah, I've somehow managed to not buy one of the old tech ones. I mean, one day I'll slip and I'll buy one because they're so cool. I've also so far, knock on compressed particle board, I have not bought one of those modular tech scopes yet either. So what's this? I literally bought this at Goodwill for 30 bucks. I don't know what model it is. Wait, I know. Actually, it says it on the spine. It is a Samsung Notebook 7 Spin. There you go. HP probes are so expensive. Yeah, I was mad when I didn't get that. Anyway, all right. So what we're gonna do that's gonna make this real weird, we're gonna leave the oscilloscope menu and we're going to go to intermodule. So we're going to need the oscilloscope. We're going to group run that, and we're going to need state timing A. We're going to group run that here. Or do we lump that? No, I think we put that there. That will leave B independent. Okay, I think we do that. Okay, then we go to here, and then I think, yes, we can add this. All right, Phil, do you know how to do this without it having just adding every single pod input? Because it's always so annoying that it does this every single time. This might be one of those UI quirks that was fixed later, but just like every single time. It's so annoying. All right, done. Not correlated. Okay, group run. And boom! There we go. Edit the labels and state timing first. Okay, I'll try that. Let's see. We're talking about woven cables and pods, aren't we? Yes, those are stupidly priced. Yes. Yeah. Well, I was also talking about the like 2-meter probes that should have come with this scope. So default label contains all the inputs on pod. Oh wait, that's right. I forgot. I'm supposed to go in here and I'm supposed to make like a. Oh yeah, how do you do this? I think we do this. Done. Can we modify label? Yeah. So let's just call this FDC. Done. Okay. I don't remember. Can you label the individual ones here? Took you 2 years to find a set of those. Barely even use them. Oh. They're so hard to find though. Okay. So yeah. The way that this system works, okay, for those of you who don't know what this is, you can do some really insane stuff with this. I think a lot of it with symbol utility here, which I don't even know how to use. It's going to take forever to boot now. You can get like sockets for like a 486 for this thing, like an actual CPU that you put the CPU in the socket, and then it has like a cable umbilical that goes into the motherboard, and then there are probe pod connectors where you plug these into that, and then you would have like a label that says what all of the pins on the CPU are. So you could do that. So yeah, the labeling stuff, you would actually spend a lot of time setting this up. Let's see, test. I don't know exactly how this works. You use that to load program code and labels from an assembler. Yeah. Create label for each one. Yeah, okay. 2-meter probe, subject of compensation. I'm not sure what you mean. Along the left side, set your names, then assign a single pin. Oh, okay. All right. So... Oh, okay.
And 3 subbed as tier 1 and says unlurk clerk. End of line.
Engine, thank you for the tier 1 sub there, and for the 30 months. I had to think about that too much. Thank you. Thank you for the 30 months. I very much appreciate that. Okay. So we could call this FDC seek. I mean, but we don't have enough that. Just call it SK there. Okay. Yeah. Oh, well, yeah, Marion, yeah, it would cause problems like that. But what you don't understand about this thing is this logic analyzer, okay? We're talking, it's this unit right here, okay? The ports are on the back of this. The unit itself is 30 inches deep. So in order to just get to the front of the unit back to where probes would normally connect, you need 30 inches of cable. So a normal scope probe like I have down here is like at its maximum extension just getting down to the table. It's ridiculous. So these are meant to have specialty long probes to work with because they plug into the back. It's super dumb. That's the problem. Yeah, well, Jacket Clubs, we got multiple things going on. Get some B and C cables and couplers. Yeah, you don't think I want to do that. That's like a very bad idea. Didn't know it's such ridiculous. Yeah, no, it is. It's very, very dumb. Okay, that's our configuration. Go back down to, no, let's go to oscilloscope. Okay, FDCSK, perfect. Okay, so now state timing. Oh, that's way better. Okay. All right, yeah, see, I need to spend a lot more time learning how to use this thing. All right, so now I can also, why is that not showing up? I think I screwed that up. Wait a minute. Is that correct? I think that is. I think that's ignore, and then, or this one's ignore, this one is add. Okay, maybe I need to stop and restart it. Maybe I should double check it's still connected. Feels good. Huh. I mentioned the scope carts. They work 6500 sit on the cart with a monitor on top. Back to 6500 pointed at the table. Device was on. Yeah, that would make sense. Okay, that does make sense. Yeah. Yeah, Fuzzball Fury, I was initially tempted to do that, but the problem is the attenuation of the probes. There's a reason that they're they're very specific. So, I want to spend a few hours ask my HP logic analyzer question on Discord. Happy to teach you some tricks. I might take you up on that at some point. Text would probably be better, just for like having a record to go back through. Yeah, this is one of the things I really need to spend more time learning how to use, because this thing I know is like ridiculously super powerful. It's just every time I go and try and use it, I have something in particular that I would like to do like now. But that's also why I'm kind of trying to use this for this project, because this is not like an immediate need type thing. Well, now it's not even triggering. What? Everything's still connected. That's weird. What changed? Scope's kind of cool, but seems over-engineered. So culminated, it's very definitely overkill for what I'm trying to do right now. Let me be extremely clear about that. Transition adapters for CPUs, when you get into that realm, they're incredible. Yeah, see, that's the kind of thing that this is meant for. You can debug a CPU with this thing, okay? That's what it is. It's not over-engineered. This is not the correct application, okay? This is going to the grocery store in a 18-wheeler semi. I don't know why this isn't triggering, though. That's kind of bugging me. Polarity set correctly? Nope, for giggles. Just gonna bring all of these back. Don't shut your overkill ways. Oh, wait. It is there. Why is it not being recorded after? Let's try this. Actually, I'm going to go back to this. I'm going to clear all those. Bought one at an auction, a hard drive full of tools, it captures hard drive manufacturer. Oh my gosh, that's amazing. We're watching a cycle come off the hard drive and the DSP processing chip. That's incredible. Mine was super boring. I still have the hard drive for mine, but I did replace mine with, I think, a compact flash adapter, some kind of solid state nonsense. Oh! Wait, 15 instead of 0. Why is it like that? That's a good catch. I did not notice that. What on earth is that nonsense? Yeah, problem found. Very good catch there, Mighty Halo. What the heck? But also that one kind of looked like, I don't know, group run. Ah, who would have guessed it works better when it, it's functional. All right, there we go. Ugh, idiot. Okay, well, fine. Typical student error. I'm sorry, I didn't read. I think we're going to take a minor detour here for a second, all right? So let me explain what I would like to do that I did not consider beforehand. So I set up this nice breadboard thing so we can probe stuff coming off of the floppy thing here. What I did not consider is that I might want to just plug the probes into this, and I don't really have a good way of doing that. So we're going to detour for just a moment. There we are. And I want to do a little bit of soldering. We're not going to actually use these, but I want to take some headers. Okay, because I don't have any like really tall ones, and I just want to solder them end to end. That way I have a male-to-male connection that I can plug into the breadboard and then plug the probes on top of. So I think that would be a good idea. I'm not going to use these ones. These are my fancy colored ones. These have matching jumpers. We bought these for the CM153 clone card. I don't want to dip into this stash. So let me grab my plebeian jumpers. Also, darken this just a touch. Okay. Something more along the lines of that. Okay. I'm going to grab a cable. Actually, I'm just going to go grab another random floppy cable because it's easier to walk over and grab a floppy cable than it is to count to 17. Okay. Just gonna plug this in. Boop. Okay. Grab the last pin. Bam. There we are. Now, I'm gonna stuff that down in there. Oh, it's a second extension. I didn't realize I had two of these. I have this weird, like floppy, but has like a male one in the center, but it's also not twisted. I don't know what these things are from, actually. I just, one day they were in my collection. Okay. Logic flawless, yeah. Okay. So we're just, like I mentioned, going to solder these direct to each other. Actually, plugging that in is probably not the solution. I'm used to plugging stuff in before soldering to it because it holds it in place. But in this instance, it's probably not the way to go. Okay. Yeah, just going to solder those end to end. Easy enough. Those cables are piggyback tape to piggyback tape drive. Oh, that makes sense. Had not considered that. Okay. This one should be a whole lot easier than that other breadboard splitter thing that I made today. That was a nightmare. Glad I did that off screen because it sucked. Okay. There are smart ways of doing this, and then there's the way that I'm going to. Actually, I should flux these. All right. See, HP6500C only has high-density connectors, no individual wire pods. Only high-density connectors. I'm not sure what you mean. It's not the, like, fabric woven things, right? Because the pods plug into the ends of those cables. Also, those cables are just like 40-pin IDC, so you can get like a IDE cable and then break them out. with that if you are desperate. Bad. No, bad. All right. Wonder how strong that is. Enough for probe pods. Okay, there we are. I don't know what it's called off the top of my head. Here, I can show you what mine is in a little bit. Just a little starter bridge. Yeah. Yeah, I was contemplating like putting some hot glue along there, but you know what? That sounds like more work than I really want to do right now. So let's just move along. It's actually slightly stronger than I would have guessed. Okay. Back over here. All right, so are you saying, I'm a cat, that your thing ends in this? Because yes, this can plug into test fixtures, but it can also just plug into these pods. So you need a probe pod. That's what it is. There isn't really anything special about these. I believe they just terminate in, well, they actually terminate, not in the clips. They terminate in individual pairs of single, like 100 like DuPont connectors, and then there's a ground up there. So they're not that special. Matter of fact, I am about to swap out which one I'm using here. Where's my collection of them? That's one right there, I think. No. Well, there are hooks. Where's my... Oh, there's the tool bag, or the bag. The probe pods don't come with the hooks. By the way, you'll get a kick out of this, Phil. There's the original software distribution for a 16500B. Yeah, here we go. This one doesn't have the hooks, so I'm going to use this one over there. Actually, the one that I have out might be the only one that has hooks. What do I have up here that's on a stand? Oh, wow. Oh, that thing is dead. That's why. Okay, never mind. Anyway, I'm going to swap out for this pod. Because this one doesn't have any hooks on it, and I don't really want to start removing all of the hooks. So we'll just leave this one aside for now. See, nice they have the software. Hook's the easiest part to find. Oh yeah, the hook parts are easy. The breakout pod is awful. HPE high density probe adapter. Huh. I don't know. I would have to look that up. I'm not familiar with that offhand. Okay. So, take that out of here. Plug this in. All right, now I can plug probe 0 into the one right below 40. So right there. And boom, we now have our seek permanently connected. Okay. This is where this thing's going to really start to shine now. So, from here, we can now just use the scope as our exploratory one. So I'm going to go back to our pinout. And let's investigate our next pin. Designing, debugging into PCB, you have pads with micro Mictor connector. I don't know lab builds. I don't know what a Mictor connector is. Mictor connector. Oh, that's awful. That's what I'm a cat's got? Oh, I'm sorry. Yeah, that sucks. Yeah, I don't know how you work with that. That's unfortunate. Is that what's on the other end of my cables? Is that what's on the main board in there? So you might just have like some kind of extension. Huh. You don't work with it, you design it in? Yeah, yeah. That's actually a thing that I might do here today too. Oh, wow, we're 2 hours in. Okay, probably not. I might do it tomorrow. I would like to design a probe board. I've designed this thing. So this is a breakout board that lets you connect two floppy drive cables to one host, and then you plug a switch into it, and then you can switch between the motor and drive select on these two, so that you can have like 3 drives on one cable. But I kind of want to take that concept, and instead of having the floppy switch stuff, I want to have all of the floppy signals broken out to a basically what I'm making on the breadboard here, and then we'll have a labeled PCB with all this stuff, and then I'll know what the ports, the pins are, and then I'll have a configuration on the 16500C to watch this stuff. Ugh. Blockchain analyzer probes, little gray blobs near the grabber ends, or termination adapters. Oh, okay. Well, that complicates it then. Then I might need to look up a schematic for the probe pod, because I would like to just plug the 40-pin IDC connector directly in with a box connector. So I might need to look up what the passivation is. Maybe I can just measure it. Okay. So the index hole should spin like constantly. We should get one of those for every rotation. I kind of want to try that. We're not going to get it. I'll have to put a disc in now. Now that I think about it. But I'd kind of like to see that. So let's put that on pin 4. So 1, 2, 3, 4. And I'm going to grab a random disc. Pop that in there. How about, that might be the print shop floppy. That's fine. Okay, Agilent application note, probing solutions for logic handlers mentions passive network. If you really want to do that, IDC 20 termination adapters. I would have to look into finding the termination adapters. So, index is not always on pin 4. I don't know how else it would be, because the cables have to be kind of standard. What's happening today? I am just exploring interfacing with a floppy drive with the intent of making a floppy interface adapter kind of thing that's a lot more complicated. Okay, back to this. Let's stop. Okay, state timing. We'll add turn label on, modify label. Call this FDC. Actually, how about FD and then IDEX? I'm gonna call this FDSEK. Okay. Can I just, nope. All right. Opossum, if you could put that in Discord for later, that would be really helpful. Your Apple ImageWriter printer used the same model of ink cartridge, ink ribbon as ImageWriter 2. Maybe. I think they do, actually. You give me 10 seconds, I might be able to find a ImageWriter 2 cartridge package that also says that it's compatible with ImageWriter 1. That says Style Writer. What on earth is a Style Writer? Never mind. Or wait, no, I swear I have them around here. Is that them? Hold on. Oh, that's weird. Okay, it claims it's ImageWriter and ImageWriter 1. I don't know. Huh. Okay, here we go. ImageWriter 1-/2. So it is 2 as well. Stylewriter was named for inkjet. Ah, okay. Ubadi says thank you. Okay. All right. Back to here. Actually, back to here because I left it on GIMP, not that. This. Okay. I guess I can click links. Ooh. Data sheets. Oh, I just download. Wait, is this still relevant to the 16500C? Oh, why do they got some stupid web viewer? Gross. Now I regret clicking view instead of download. Atari Fuzz, probably not that much. I just tend to use modern systems as modern. Oh, there's some fanciness going on there. Ah, there we go. 40 pin. Okay, so it is still going to be relevant. That's amazing. Ah, all right. So, okay, I'll have to take a look at that more later. It looks like that will be relevant. All right, not that. This. Okay. Back to here. It's a later version of the one I was thinking of. All right. ImageWriter LQ, letter quality, basically ImageWriter 3. An all-put name, all right. For 40-pin probes, you want to get a copy of the older version 2. Lists some adapters which aren't available anymore. All right. I'm probably going to just have to make my own because this stuff is really hard to find, as I'm sure you're aware. So I'll see what I can do. All right. Now I can add... Aha! I wish you could reorder these. Okay. Wait. Maybe it's just copied the data. I think they're passive. Okay. Why is it not triggering now? Because I have the trigger set for the analog, and analog's not connected. There we go. Okay. I imagine I need to bring this out more. See the index? That doesn't make sense. There's no way we're seeing multiple tracks, but not an index. There was the index. Why is the index so infrequent? Why are we getting... Maybe the grease weasel, maybe the clean routine just doesn't care. Maybe that's not the most valid test. All right, hold on. Let's prep a different command. GW raw. This is going to go drive B, so actually... I may not go to drive B. I might have actually modified this. Oh, I want 40 anyway. So B, but make this A there. Okay. GW raw 40. Okay. Now when this runs, I think we'll see index in between the track pulses. So I'll probably zoom this out a little bit as it goes. All right. And go. And it errored. Invalid option A. What? Oh, that's my test. Okay, back to this. What are we getting? The like track steps are too infrequent now. It's missing them. Huh. All right. Uh, Probably only 10 microseconds wide. Yeah, I'm thinking that might be a little too fast. Trying to... How do I set what the trigger is for the state timing? Is it... Hmm. So I think I want to try triggering on the index pulse. But I'm not exactly sure how to set the trigger. Probably bump this up a little bit. Yeah, I've heard that, Phil. That's Really disappointing. When I heard that, I took apart my 16500 to make sure there was nothing like that on there too. Okay, so there's our index. Ooh, all right. So we have data to snoop here. All right. So, oh, excellent. We got it. There it is. Oh, that's so cool to see. So we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 revolutions per track. That's weird. I wouldn't have guessed that. It's 3 revs is what I have the grease weasel set to. I wonder if it's having to do multiple rotations. But we're getting it. So these are the track seeks up here, then the index hole. So each one of these represents a full disk revolution, and then this is switching tracks. Oh, that's so cool to see. Okay, we're making progress now. All right, now this is actually doing something. Okay. That was real progress. Let's figure out the next thing we want to poke here. I do kind of want to do the motors, but those are just going to be one thing. Let's see. We got read data. Kind of curious about that. Yeah, you know what? For giggles, let's just try data. All right. I don't expect we're going to see too much useful stuff here, but we're about to flex capture with the logic analyzer. Just for giggles. All right. So, starting the grease weasel now. Starting capture. I totally screwed this up. No, stop. Hold on. It would be really smart. I need to just delete the files. It would be smart if I set up the probe first. Have we broken it yet? No, we've actually gotten some real good work going so far. No, stay in this menu, configure this pod. It detects it now. That's kind of cool. Okay. Format 1. So we're going to call this, turn the label on. We're going to leave it positive trigger, I guess. Actually, I should probably set this to be negative trigger, now that I think about it. At least that one. I didn't pay attention. I think the other one was negative too. We're going to call this FD RWRT, right. Or wait, are we doing write or read? Now I don't remember. Wait. I was read. Why would I do write? I'm not that stupid. Hold on. Computer over here is doing stupid things. Okay. FD red. Ugh. Okay. Done. All right. Waveform. Now we can add the data that's red. Okay. And I need to go here. Of course, you fire up the 6500 a weekend. I'm busy. I have to pop in and out. Sorry. It was slightly spur of the moment. All right, here we go. Starting image, and why is that just instant accumulate? Hold on, run. No, why? Run. Repetitive? And it sees data happening. Where's my data? Wait, is it because I have the delay set? Oh, idiot. Hold on. 0, done. Zoom. But why is it all... Oh, I bet the write data or the read data is filling the buffer completely. That's probably what's happening. No, there is no trigger. For some reason, there is no trigger. I don't know how to set a trigger. Unless I have to set this to binary. This looks like a Zachtronics game. Oh, okay. Maybe I have to set them all to binary. RM -R test. Okay, that didn't work. I almost did it blind. Hopefully I didn't just delete my home folder. Wait. What did I do? RM-R test and GW raw 40 test. Okay, there we go. Now we can go back here. Run. Okay, so we got, again, it does not run that long because my guess is we're filling the buffer completely with read data. The trace screen. So, pattern. Yeah, sample period. How do I change the sample period? When I hear it seek and then I see this go. That's kind of amazing. Okay, feature requirement, okay? We need LEDs for step and seek and index. We need LEDs for index and seek. Cause like watching that is real cool. Okay, that's a requirement. Change the sample period. Okay. Where I can't change it there from the looks of it. Yeah, so this is present for, I don't see a sample period there. Format, configuration. Ooh, whoa. Well, direction's not really that helpful because it's never going to seek backwards. Because this always just seeks to track 0 for right now. Read data. What does seek do? Seek is the step. It's step. It's not actually seek. Yeah, and IDX is the index hole on the disk that as it's spinning. Yeah, for our current tests, direction is not going to do that much. I believe direction is high or low, and 1 is something for one direction. If it's one way, then it receives a step sign or signal, then it steps that direction. If it's low, it'll step the other way. I don't know. Yeah, but I don't know. I called it seek. It doesn't really matter. Right now I'm just trying to figure out how to set the thing. And yeah, it's a very small character limit. Very, very small. I probably can stop prefixing everything with FD. But yeah, where's the sample period? Like tell the analyzer what mapping is done, define symbols in map, step in, step out. Yeah, see, that kind of stuff would be awesome to do, but that's going to be way more complicated. So yeah, you want this. So pattern. Wait, hex. Clear. Done. Binary. Range. Symbol width. Oh, it's so complicated. Anyway, you can't set the sample period like Ben. It stores transitions, current pod state, timestamps, and not samples. Okay, yes. So the length of the labels. Oh. Wait, what? Huh. Pattern, start, stop. Okay. Apologize for the whole symbol tangent. I mean, the thing is, I've always wanted to learn this. It's just really complicated. You know what? Let's ignore this for right now. All right. Let's just not. Set the radix in trace window to symbol. It'll decode. Oh man, I would love to figure this out. Stick the explanation. I would actually really appreciate that. Because my assumption is, okay, let's say we do measure the direction signal, okay? So let's say direction is high, all right? And then it sends a seek command, a head step. Could it combine the two things and then know like it's seek plus or seek minus? Is that how that works? Because I think it can do merged things. I don't know. It's so advanced, and I really need to just read a manual for it. But it's also one of those things where you can just like start reading the manual, and then it'll start explaining something that's like ridiculously complicated, and then I will have no idea what it's talking about. Because it's, yeah. You assign step and dir to both a single label. Okay. You know what? For giggles, let's spend a little bit of time on this. Okay, what is... I would actually like to learn this. Direction, pin 9. Okay. We're going to make connection 3. We're going to stick this one on pin 9. Yes, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Who would have guessed? It's right next to the step. All right, back to here. Go here. All right, let's do a little more work. Okay, format. Turn label on. Okay, so we'll add this one. Done. Okay. No. Symbols. Step. Dir. Oh my gosh. Step. Dir. Okay. So this would be a good one to test with clean, because clean actually moves the head back and forth as it does this. Okay, then add, okay, pattern. Oh, now. So it's parallel. Okay. So pattern. All right. Okay. So do I... But how do I add more? So that's what this is, Ben. So this is the step pin, this is the dir pin. So this label is only these two. That's no problem. And add a row for each valid decode. Yeah, so what I'm missing... Okay, add symbol. How? Label. Stay here, symbol width. Click on the symbol. Oh! Okay. Well, in this case, step, other. Oh my gosh. Because I don't know which is which. So we'll say that this one is 1 and 1. No, it should be 0. This is either 0, 0 or 1, 0. So, okay. Oh, man, okay. Base binary, all right. How did... Oh my gosh! If I were debugging a Centronics printer, okay, parallel printer, so all the signals are all at once, okay, I could program carriage return, line feed, A, B, whatever, and then have this decode it like this. And then it would say, okay, we gotta, hold on, hold on. Symbol width, we'll just go like 11 or something. I don't know how long that is. Oh my gosh, it's done for you in ASCII mode. Okay, but let's just pretend that, I don't know, I'm connecting a parallel port backpack drive and we're trying to debug what like the CD command is for start CD playback or something, okay? Let's pretend it's that, okay? We could figure out what that command is. This can't output back, can it? What do I need to buy to be able to send this data back? Oh my gosh. Okay. So we go to waveform. I can add seek. Oh, what's this now though? Hold on. Delete all. Continue. Okay. Let's add. Is there a symbol? Okay, how do I add this? Oh, wait, you're saying I need to for a trace symbol. Okay, pattern. But how do I pattern? How do I pick these? Pattern. Oh, okay. So it's saying the pattern is absolute. It matches these. And it would show those. Think I'm too tired for this? I'm a cat. I always feel too tired for this. The difficulty with this is that there is nothing to grip as a foundation to then learn. And this is, I feel like, the closest I've ever gotten to setting a foundation to figure out where to go from here. Okay, add the label to the trace. Okay, trace. So we have the symbol here. Add the label. Absolute X means it doesn't recognize a pattern in the symbol table, so it's showing you an absolute binary value. So you're saying currently it doesn't match? Whatever is in the buffer right now doesn't match, or this is the wrong screen? Okay. Format. Where you set up triggers. Okay, format. Is the pattern you selected for triggering. Go back to waveform. Okay. Add seek. Okay. Adding. And then set the radix to symbol. Okay. So we click. Okay, I can't click anything. Markers. Radix. I don't know what the radix is. Delete all. Okay. Click channel mode. Okay. So channel mode, individual or overlay. I could see it being, need to add it to a bus. Okay. See, we're getting into the parts where why I've never figured this out before. Overlay. Okay, and then we do this. Okay. All? I don't know. All right. That's different. Had all the channels together. Okay. For giggles, I'm just gonna like GW clean watch dash N 15. Also, that didn't work. Oh, there it goes. Okay, 15 seconds is just like not... It's too short or too long. Okay, hold on. Make it 5. Turn your delay to 0. Okay. Delay 0. Okay, it's going. Huh. So I'm not sure what it's showing now. Can you tap where it says waveform 1? Yes, this. I'll go ahead and stop. Think you should set the radix on the label screen. Set it to symbol, it should decode. There. Okay, so you're saying here? So when you say radix, I really don't know quite what you mean, because I don't see radix as a term anywhere on here. So format 1. Can never remember what HP called the screens. Okay, labels, triggers, waveforms. No, it's format, trace, waveform. All right. So I do have patterns that are not there. Where symbols are much more obviously useful in a state capture and timing. So use them when defining triggers. Okay, tap FD. So we can change which label on the other screen. Okay. That only lets us like disable it or enable it or rename it. So we can turn it off, we can rename it, or we can turn it on. Modify label does nothing other than rename it. Radix is base on an HP. Base. We don't have a thing there. Okay. So I think what you're looking for then is in trace, you want it to be set to symbol, but then symbol, I can't click anything here. I don't know what the offset does. So do I need to... Do I need to handle all possible cases? Is that it? So do I need to go add the like no step cases, and then it wouldn't add absolute? Because I think this is where the issue is. Set that to symbol. You can specify the value if you want it to matter for triggering. Okay, don't need to cover all cases? Okay. So set that to symbol. Then you can specify the value if you want it to matter. So I can't click one of these patterns to set. Yeah, I don't have a trigger. I don't know how to... I don't know how to set a trigger unless I do this. Absolutely, is always there. Okay. Wait, what now? Why did it show $? Wait, why is that weird? Hold on. The falling edge. Okay, so let's say it stays and then it falls. Or is this it's up and then it's down? I'm gonna just for giggles. Okay, we got something. Dir never seems to change. Okay, there was something. Maybe for Dir. But it was a pulse? Waiting for trigger. Also, what is it triggering on? Dot down arrow means it'll trigger on a falling edge. Okay. But on which pin? Because that's confusing. Because we're looking at a symbol now, I think. Is it on any? Also, I'm guessing... I'm going to guess Dir is down when... Oh, that's probably one of the best captures we've had right there. I'm going to guess Dir is down when it's going forward. Because it seems to be down most of the time. So that'd be 0 for forward. You assign them to label, they're assigned bits. From left to right on the screen. Okay, wait a minute. Hold on, it's not a dumb backwards LSB nonsense like it was on the other one, was it? I didn't think about that. The format screen. Okay, format. You assign them to the label. They're assigned bits from left to right. So this would be dir, or the dir pin, and then the seek pin. And then I assume it's the same order. Didn't have to reinvent it by reverse engineering. I technically have some kind of documentation. I think it's in the other room. No, it's right here. I don't remember what exactly it is. And I swear they printed it themselves. So I have 97 user's guide and then a front panel operation reference for the logic analyzer, which is like 600 pages or something insane like that. I don't know. I never really paid attention. This is a really nice copy, if it is a copy. I have no idea if this is original or not. I bet it's not. Okay, your bits are dir seek. That's how you connect them up. So FD seek 1, 3 pod. Yeah. State analyzer. Oh my gosh, there's like hex and stuff there. That's ridiculous. What on earth? Whoa, hold on here a moment. What is this doing? State, trace, specifications here. What in the heck? If I keep going for the well, they're both cherry keyboards. The touchpad one. State analyzer is where you clock it externally. This is timing. So state, just for giggles. I just want to look at, this is trace 2. Yeah, this can be utterly maddeningly complicated. So I'm looking at this. You can do like logic stuff. Dude, this thing is crazy. Boolean things going on in the middle of the decoding? Holy moly. So complicated. Okay, we don't want to clock anything ever, so we'll go back to timing. It makes sense, Phil. It definitely makes sense. Yeah, if you lock to the PLL, and then you can know exactly when cycles are happening, yeah. I guess let me flip through this manual a little bit. I would like to see just like a screenshot of something that is what I think we're trying to do. So just to be clear, I think the end goal we're trying to do here is it should print step-dir, step-other-dir as text in the waveform view dependent on what it is doing, right? Like that's the goal. I don't know how there'd be some kind of block printed in here and it should just have the text that shows that. I think that's what we're trying to do. So I would like to like see that there's an example of that. If you zoom in enough, it should. Okay. So I just want to see if I can get a good grief. Yeah, state is apparently insane. This might also talk about what the probe doodads are. Oh, hey, look! Boom! There's what the probes do. Okay, so we got an op amp. I don't like that. Oh, probe. Okay, so there's a resistor and a capacitor and ground, 8 picofarad. We got 90K a cable. Okay. So, okay. So I need an 8 picofarad cap. That kind of sucks. I don't know. Did I specify what the resistor is? 100K in parallel. Okay. But wait, in parallel? Isn't that it? Isn't that in series? If you're buzzing your code. Oh, I'm sorry there, Ben. Here, let me apologize on your behalf. Ben's not a rude person watching with the speaker television loud. Sorry. Okay. Connect the probe directly to test pins of your target system. Do this. Pins must be, yeah, square pins, round. Each probe has an input impedance of 100K in parallel. Yeah, okay. Well, I was looking at building a PCB for the floppy interface, so we can just plug a probe pod directly into a floppy thing for measuring stuff. I would like to be able to do that here. So 2 resistors are in series, in parallel. Two logic analyte. I'm not sure. Anyway, we'll come back to that. We'll come back to that. I would like to find a picture of like what our objective is, just to see. Although we might, let me try running this one more time. Okay, so you're saying now I have data here, okay? So I have, that's the wrong input. I have data. So what you're saying is if I zoom in, yeah, I'm going to guess that it's not doing it. Pattern. Specify patterns. Why can't I do this? Base symbol. X marker. O marker. What? Leaving, entering, offset. 0, 0. Done. One, 0. Done. Okay. And search pattern not found. Okay. Oh, I think we're close. I think that might be something to do with it. X and O. Where are the X and O markers, though? Wait, now I can't set an offset. Oh my gosh, this is complicated. What? O pattern, 0, 1. X pattern, 1. Not 40. Wait, what? That means it's not. How can it can't be 40? What? Negative. I don't even know now. Wait, you must spin the wheel? How do I do it with a keyboard? Is there literally no way? Hold on. Waveform, format, no. Trace, pattern, click. Okay, so now we would trigger on stepping going out, I guess. So this would trigger on anything. That would trigger on any falling edge change. Oh my gosh. Definitely equipment designed by people with PhDs for people with PhDs, yes. It's the wheel or nothing. So it's I don't mind the wheel for when you're working, you know, just like rah, 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 on it. But when I have the keyboard connected, like how do you do it over X? Like, what? Is it just not possible? There's gotta be a way. Not numbers. It's not arrows, because that moves the selection around. There's gotta be something I'm missing. Functions or numpad. It's not numpad. So note in the manual about how the wheel translates to X. It's a shortcut key. Control. Shift. Aha! There we go. Well, actually, hold on here. Absolute, any pattern. Okay, yeah, sure, that's fine, whatever. Okay, I want to go waveform, shift. Oh, okay, that's super nice. Okay, I am very, very happy to know that. I almost want to write that on a post-it note and just slap it on the front of the machine. Oh my gosh. This thing, man, I tell you. Ah! Okay. Is there a timing demo state connecting to probes? Okay, maybe there's like an index at the beginning tells me where timing is going to be. Hold on. I would really like to. Yeah, that's nice and obvious. No kidding. Yeah. Oh my gosh. Found it by accident. Up, down, didn't work. She expected. No kidding. Oh man. Okay. Chapter 2. Okay. User interface. Key features. Okay. Probe ground. All that. That's how you like probe. Okay. Chapter 3. Front panel. Using menus. State time configuration. Timing. Okay. 4.3 through 4.7. That's what we want. Okay. It's super short. Using the menus, it's pages? What? Oh, this is just the menu map. That's useless. Okay, menus. State, timing, configuration menu, timing, state. So we want 5.8 through 37. Okay. Okay. Timing and state, menu specification. Okay. This Windows user discovering the shift key. Well, you are in the rare exception where I'm actually running a computer with Windows because I'm running this laptop only to control my Extron for switching HDMI inputs. But no, I'm a Linux user. It's just that this is very, very weird. Okay, label. All right, I just want to flip through this to see if they show a decoded output. What is this doing? Oh my gosh! Hadn't even considered that! You can group pods if you want to measure 8 billion things at once. So we could measure an entire ISA bus all at once as one label? This is ridiculous. Okay, we got a symbol. There's some stuff. They're setting up a symbol, maybe. They're doing a pattern that's in hex. Okay. So they're gonna do that. They got like the most ridiculously long doodads ever. Come on, go to the waveform view. Show me what this decoded thing. Okay, so they're setting it hex or whatever. Okay. So wait, you trigger on a particular hex pattern. This is ridiculous. Discovering that Ring Book has text on both sides of the paper. Again, I doubt this is OEM. I really don't think this is an original manual. I think that this is a copy of something. This is not inkjet printed. It's, if we look at this at an angle, you can see this is like actual photocopy or something. This is a very thick ink that was laid down by like a drum or something. I'm not exactly sure what it is. But it's some kind of copy, I believe. Okay, so transitional timing versus traditional timing. Timing sample stores, I don't know, okay. Wait, acquisition, transitional, what now? Whatever. Just show me a waveform with decoded data in it. That's all I want. I just want to... What's my end goal here? Oh my gosh, there's so much about configuring this thing. Wait, now we're into state. It never showed me what the waveform view looks like with decoded stuff. 37, and then... somewhere... state. What? The laser printing the manual from their FTP. I could see that. Yes. That would make sense. Although it's got to be an older, like, better laser print. I don't know. I've never had a laser printer that, like, is this nice. Oh, this is for the A. That explains why it has the Sony drive there. Okay. Is there a waveform manual? Original would have been in 3-ring binder. Yeah, that would make sense. How did they bind this? The hole punch to, like, do this is insane. I mean, I guess you just do a few pages at a time. Okay. State timing analyzer. Interpreting the display. Waveforms menu. Okay, so maybe we go to 6. Sure, picture of original manuals? I would be curious. Should probably start a running search on eBay just for 16,500 in general. Try and collect some of that. Oh my gosh, that's just torment. It's so thick ink, I can feel that. Let's see. All right. Show me something decoded. Just anything decoded. I assume if I can see something that's decoded, then it'll probably be near the documentation that tells you how it's done. Wait a minute. What's going on here? What's mixed display? When both state and timing analyzers are on, you can display state listing and the timing waveforms. Wait a minute. Is state listing menu? Huh. Okay. I guess state is different because it would be by the clock that you set. Huh. HP Logic Analyzer? Right there. We're analyzing Floppy interface right now. At least attempting to. Can't get it always. So it weighs like a lot. I kind of don't blame them for not being able to just pick it up on a whim. It's ridiculously heavy. So if it's really like behind something, you actually have to try and get it out. It's not easy. Okay, timing analyzer. This might be, we might be on track here. Okay, come on. Show me a thing. No, I don't want state. No state analyzer. Don't care. Okay. What's clicking? Just making sure there's nothing on that's not supposed to be on. Okay, using a state timing analyzer. All right. State trace specification. Okay. Labels, doing something or another. Using a printer. I'm wondering if maybe we can't do it without it being state. Here's what you need to order to do the whole 8088 or 8086 or 8186, 386. So what I was saying, you could measure a, well, that's the 6802. Maybe the 486 didn't exist yet. 68K. Okay. Yeah, this thing can literally, these are These are giant, okay? I know that Tube Time has some of these actually. So they're like the size of this sheet of paper. And it's a massive thing. You have to plug the CPU into this, and there is an umbilical cable that comes off, and you plug that into your main board. And then there's all sorts of probe sockets that you jam the probe cables into to work with it. They're ridiculous. Hold on, installing new logic boards. No, we don't need that. Yeah, it's just, but I didn't see a decoded view. Might be one of those weird things of fixing it. Sure, you can display the hex values and symbols in the waveform. Yeah, I don't know. I didn't see it there. You know what? That could be one of the things that it does without using frame buffer hex. Maybe it can't display text on top of the waveforms because it doesn't draw them using X commands. That could be it. Well, I guess that just means I need to get a 16700. Okay, so we're not gonna. I'm now predicting we're not gonna be able to do that because yeah, you said the 16700 over X. You can see the waveforms, so I'm gonna guess they're just drawn completely differently on there then, which could make sense why it would be able to show the text too. Because yeah, I didn't see anything in there that showed it decoding stuff on the fly. I think it might just be for setting triggers, maybe? I'm not sure. I don't know why you care so much. Well, I mean, we would care about specific triggers. Like maybe you're having an issue when you're trying to read a specific address and you can debug that RAM chip is bad or something. So maybe you'd care that much. Okay. I'm just trying to figure out where we want to continue from here. So we definitely can probe and monitor stuff. And we've gotten a good start. I'm actually really happy with how much progress we made on the 16500 still. So what have we not probed that we realistically could? We definitely got data. We just can't do anything with it. Decode on the waveform display only shows up when you have XO measurements turned on. So I was trying to do something like that. If I go to markers, pattern, okay, so X pattern, what is the X pattern? The training kit or training kit manual, work through that, teaches you a lot about. I would love to try and find that, yeah. You pick a label to inspect at wherever the cursor is. So the cursor's just like kind of in the middle there. But X pattern from trigger. Wait, so the X pattern is the trigger. What's the pattern 0? Hold on. So if we go to trace, let's say step-dir is our trigger, all right? So we go back to waveform, but X pattern from trigger, and it's still 0. What? X marker, entering step-dir. What menu did it just open behind it? Oh, it's some kind of configuration thing there. Okay, markers, patterns, makes the analyzer search for the patterns you choose. What's markers? Okay, hold on. So, yeah, we do pattern. Specify pattern, step-dir, and other dir. Entering Stop measurement when... Oh, that's weird. Okay, no. Done. Pattern not found. Could I... I don't think it's going to be this. Okay, we can try that. I'll set this back. So pattern. So why can I enter a value here though? What is this value? Yeah, so I added them back all in overlay mode. But what is this value? that's really weird. Also, really quick here, I'm just going to bring this back to a point where I can start the data again. Value is the nth time the scope saw that pattern in the buffer. Okay, so I do want it to be 0. This I probably also want to be 0. So it's calling that X run. So it's still not overlaying it though. That is a target. Dash line is one of your markers. Okay. So 3 or 1, maybe just 1. Hold on. Clear 1. So we have the markers are, yeah, they're overlapping. The markers are really left. You have 1 bit set, 1 bit clear. If step happens, both bits are clear. Yeah, so I get what you mean. It's probably, I mean, one thing is down here and up, and then they're both down. They're both, one is up, one is down here. I get that. But middle of step happens, both bits are clear. I thought it was supposed to be falling. Okay, so that didn't work. Why is it not triggering now? Pattern 0 not found. Well, Phil, you see what I'm doing? Because I don't. Yeah, I'm slightly confused here. Okay, so hold on, I want to try something really quick. If I go to format this thing, activate that one, done, trace, yeah, wait a minute. Yeah, okay. So this is not steady state and then it falls. This is not a history of what's going on. This is each individual channel. So we want, let's make sure we get rid of this. Anything. Or maybe we don't even want, maybe we don't even want the present for? XX, then find, which is really the falling edge of step. Trigger. Yeah, so which one? It's dir and then step, so don't care, and then falling edge of step. And then we can go waveform. All right, hold on. You're not going to get a command line logic analysis system. Okay, so we kind of got a thing there. So our marker... So this is interesting. It changes the direction and then activates the step. I think I need this. Pattern, oh, not found. So it's 0, 1. Yeah, everything idle, yes. Yeah. The delay, there's a, yeah, your O pattern isn't valid. Yeah. So let's say entering. I got an idea. Hold on. Symbols. Add symbol, step, idle. All right. It can be, it doesn't matter the dir and 1. So that's, wait, what did I just change? No. Why is it in the middle? No. X1, that's idle. So anything there other is 1, 0. Okay. So that'll catch all. Yeah, so that would do that. And we go back to find pattern. Let's go with, so it's down when it probably steps forward. But it doesn't matter. Let's just do that. That should be good. Waveform. So I want X specify pattern. Let's say when we leave idle and enter pattern step dir. Oh, pattern failed. Oh, that was a good one. Okay. Man. I should put your leave idle, enter idle should both occur. Yeah, but I think it's too long. But I don't know. I don't know how much we can capture. If I could have it capture from leave idle to enter idle, that would be awesome. That would be an entire clean routine, I think. Although that'd just be one step. We'd only capture one step. I know what we need to do. Ooh, ah, I know. FD MTR. Let's track when it starts spinning the motor. Enter when it starts spinning the motor. Start logging. Or do we want that? Do we want that in here? Or I want to trigger when the motor starts spinning. Then it'll start seeking or whatever. And then we can try and decode the seeks while the motor is spinning. And then we can capture the entire time the motor is spinning. I don't know. Maybe. Okay, so we enter. Let's say we enter stepdir. Oh, marker. It should step and then step idle for sure. It's not going to work when you have read data. The capture read data is going to eat all your capture RAM. I could just disable that. Right now, we're not doing that at all. At least I don't think we are. Okay, well, we're consistently getting kind of the same thing always now. No, we didn't get it there. I could just... Is that actively reading? Maybe we should turn these off. Label off. Label off. Will we get more? That seems like a whole lot more to me. Okay, well, their problem kind of solved. Okay. Duh. All right. So, fine. Fine pattern. Let's say stepdir. Present for, I have no idea how long it's going to be there for. So let's say 10 nanoseconds. I don't know. Done. Run. Okay. So X pattern, or no. specify a pattern, leaving step idle, O marker. I don't know what the O marker is. Step other dir? We got way more steps now. Why does it step 4 times back? This is clearly the entire clean routine here now. Holy moly, it's so much data. Okay, we're good. I can stop this running. I think we could just leave this in the buffer and use this. Okay. Huh. All right. Markers and dotted lines of the waveform. Yeah. So I'm trying to figure this out. Specify patterns. Yeah, but we're not. Okay. So pattern. I'm still kind of hoping we can decode on the screen. Yeah, Phil, I do get that. That's my fault partially. I was. We're definitely decoding some data. But yeah, I'm really thinking we're not going to get it to display over this. It so far just does not seem like that's what it wants to do. Try setting it to marker time. And you should be able to spin the wheel to move the markers and see what the value of FD seek is. How do I see the value? I mean, I see that I can move the markers at marker X, step idle. Wait, what? All right. Moment of truth. Okay. Oh my gosh. That's not what I thought it would be, but I'll take it. All right. That's fine. Okay. Okay. So for those of you who are maybe not catching on what we're saying, right here we have a label at the top of the screen, and we currently have the green marker in the middle of that valley of the signal. If I push it to the left, it's step idle, all right? And then here should also be step idle because that's the direction pin that went down. So then this is probably a step forward, and then it steps one track, stops, the step is idle again. Okay. Okay. So then in theory, I would have to do a whole bunch of work to zoom out here. Oh my gosh. And then move the thing over. So we could do, let's do this. Let's zoom way out. Okay, we're going to move the X marker all the way over there. We're going to move ourself all the way over here. How's this zoom going to work? Okay, that's fine-ish.
Douglas McDodgerson gave a Tier 1 gift sub to Killer Miller X. End of line. Douglas McDodgerson gave a Tier 1 gift sub to Trap Exit. End of line. Douglas McDodgerson gave a Tier 1 gift
I think
sub
you're
to
right, Phil.
HOOZTER 9. End of line. Douglas McDodgerson gave a Tier 1 gift sub to Epineconhead. End of line. Douglas McDodgerson gave a Tier 1 gift sub to Mechatronics. End of line. Douglas McDodgerson gave a Tier 1 gift sub to IRSLA 42. End of line. Douglas McDodgerson gave a Tier 1 gift sub to C's Dead Peeps. End of line. Douglas McDodgerson gave a Tier 1 gift sub to Zobrings Bacon. End of line. Douglas McDodgerson gave a Tier 1 gift sub to Batman End. End of line.
Okay.
Douglas McDodgerson gave a Tier 1 gift sub to RUSSELLK 898. End of line.
Dogface, thank you for the 10 gifted subs there. Holy moly. And hello, since I think you just joined the stream. All right. This should be step otherder. Oh, yes. Yes. Oh, that's so good. Oh my gosh. Hold on. I'm going to try this. Symbol width 99. Boom. Okay, 16. Now we go to waveform. Step otherder. Beautiful. Oh my gosh. So we can decode the data. It just kind of sucks. Just got your wrong button. Oh, sorry. I can refund him if you want. Actually, I don't know that I can. And yeah, Phil, that makes sense as to why you would have upgraded to the 16700. Totally see that. Now I wonder if I can do it with the, is it the 1650B that I have, Ben? I don't know if you're here. I have a more dedicated one. I wonder if it can do it. Oh, this is interesting. Okay. Oh man. Want to see the addresses of peripherals in the chart? 16500 can't either add the prototype analyzer to it. Ooh, oh, wait, 16505, a prototype analyzer. Interesting. Ben scooted off. All right. Prototype analyzer. So that's whatever the controller is here, because that number was familiar to me. What's the controller? Oh, wait, that's like a whole other box thing, isn't it? That's complicated. I think that runs the 16500 software. Yeah, UX computer. Oh, okay. Runs an old version. Ah, all right. Okay, so not probably what I want. Man, okay, Phil, out there question. You don't have any pre-HP UX computer software, do you, that could interface to this kind of stuff? Just out of curiosity. So the thing I showed earlier over here is an HP Series 200. So that's from, I'm pretty sure 1981. It runs a 68K HP Basic, and it has HPIB, of course. It can't interface to this, but it seems like all of the software doesn't exist for it anymore. So I would have to program everything myself in BASIC if I wanted to read from this thing. So it's like, it would be a nightmare. But yeah, I would love to be able to use this thing to interface with that. So you should be able to talk to it. You want 16500 program manual? Yeah. So that's the thing. I could do the commands. So like I have the 1711 drawing tablet down there. I think that's what it is. 91.114, whatever. I wrote my own drawing program using that. But there should be like HP EGS out there, just as like an example. But yeah, it's impossible to find this stuff now. So, but yeah. I should, yeah, I need to, never heard of any software existing for them. Would have all been written by engineers and players bot. Yeah, that makes sense too, because you probably also build your own test bed that you would want, and then you just pick out the individual things that you would want to test it with. All right. I am not thrilled with what the decoding, quote unquote, looks like here, but that's better than nothing. I wonder what does a, it's all parallel, isn't it? I thought this, can the symbol library do anything serial? So like, let's say there was some kind of meaning to the, man, there's a big data set. There was some kind of meaning to the data over onto the side here in this area. Can it do serial decoding? No. Okay. All right. Huh. Yeah, it's still definitely useful. It's just not what I thought. Oh, we can swap between the X and the O marker too. Okay, that's nice. Okay. So it's only parallel decoding. That's all right. Okay. This was can't decode serial buses as is. You could probably write an inverse assembler to do it. That sounds like a lot of work for something it would be fun, but I'd be better off either buying something more modern or spending that time doing it a different way. So probably. Dogface, that HP Gateway was incredible. That was not e-waste. Yeah, a lot of work, yeah. Yeah, the other problem, Matrox, is I think almost all of that software has really difficult security DRM kind of stuff. So it's the people who had it, it would have been like locked to one of their computers. Like I've explained this before, the Series 200 has a PROM in it that can be read by the software, and it will, on first boot on the computer, read the PROM and then encrypt something with the serial number of that computer. And then if you try and run that software on any other computer, it won't work because the PROM ID won't match. So I could see HP doing some pretty evil stuff like that. And then people like go, oh yeah, the software is useless because we got rid of that computer. Even if we had a identical computer, it would be licensed to the other one only. So yeah, I don't think it would have been super likely to be kept around, unfortunately. So I think the NES advantage is which zapper, yellow or orange or gray. I have some original HP application discs I can't use because I don't have the correct hardware keys. Interesting. What platform? Have you flux and imaged them? Don't think the prototype analyzer software is protected. If it is, then it'll be Flex LM. I don't know what that is. But yeah, I would have to, I guess, get new hardware to utilize that, which...
Kazuto in Y subbed as Prime and says happy 2 years. End of line.
Kazuto, thank you for the Prime sub there, and for 24 whole months there. Definitely appreciated. It's got an orange, but you have a gray? Ah. I don't know. I have a really hard time buying console stuff nowadays. The last NES I bought was $6.50 at Goodwill. It worked fine. Came with a controller. So when I hear like 200, like, it was probably a good deal now, but I don't know. To me, that sounds insane, but I also know that they're not $6.50. So it's somewhere in between, and I don't know where. 16505, you're considering that? Yes. Yeah, I should get a 16700. Definitely. Isn't the 16700 that does run the HPUX that's stripped down, right? Like, this is not really HPUX that's stripped down. This is something that just barely predates UX. And I think the 16700 one, just as like one of those memories that sticks in there, is the one that someone wrote a version of Doom for, I think. So, yeah. So that would probably be the reasonable one to step up to. Do these cards plug into that? Because that would be... that would make the change a whole lot easier to tolerate. I wouldn't be surprised if they do. Maybe they do. That would be really, really nice. Real-time operating system? Yeah. It actually comes with Doom. Oh, I didn't realize that. That's amazing. I didn't know it was built in. Scope cards probably won't plug in, the acquisition cards might. Are there scope cards? Because if there are, I'm definitely going to have to keep this thing around. So to put it in perspective, one of the reasons that I kitted this thing out with 4 analog channels was for doing VGA signal analysis. So like for this thing itself, actually, the video signal is like 358 pixels wide or something stupid like that. And for other hardware, I wanted to have a device that I could see what the like front porch, back porch timing was on VGA signals. So that's why I have this, so that I can tune in my capture details just perfect. So there are scope cards. Okay, so probably end up being a whole bunch of money for another thing. Maybe. 1653. I don't know which one it is. Scope 400. Okay, it won't tell me what they are, I guess. I would have to look up which cards I've got. Yeah. Oh, that's why it's... Yeah, I forgot how this thing works. So I only see the like oscilloscope E. I was like, I have 2 cards. Why is there only one? And it's because I have a single time-based card and then 2 acquisition cards. I forget that, yeah, they're kind of weird. Yeah, all right, well, and Black Jam, your NES costs $5. Side of a produce market? Yoshi's Cookies inside. I don't know how much Yoshi's Cookies is. That's one of those games that I would always try in a collection and would be like, oh, it's not a platformer. Next. So I have no idea. That's the only memory I have of it. Yeah, all right, I'll have to look into a 16700 because that would be really nice to decode on the fly instead of with markers. But we do know how to get a state. Well, I say state. That's like a specific thing with this. We know how to get a captured packet of data and then work through it, at least. We can do that. So, emphasis on the not yellow. Yeah, there is some benefit to that. I don't think they yellow as much as SNESs, though, do they? Because those are a lot more prominent for their yellowing. The other day I saw yellowed more like orange NES. Oh my gosh. Okay, maybe I'm wrong on the yellowing. Oh, it's combined time-based scope. So, scope. Okay. Yeah, I'll need to have 4 channels no matter what for scope. 3. There's no Z. Okay. Well, I think we accomplished all of the goals that I had for today, at least. I'm trying to think of what else there is. Like I said, I kept it... the bar was pretty low for today. We might come back at this more tomorrow. Maybe try and lay out the board for a pod breakout to measure things. I think it would be helpful. So, Because, yeah, again, for those of you who weren't here at the start of the stream, the overall goal here is to lay out a PCB similar to the floppy switchboard that I made, but much more complicated, that can electronically switch floppy drives, as well as just integrate the grease weasel directly into it. It's going to add a 16:2 character display, some buttons and the configuration things. There are some things I would like it to do. I would like it to have a clean routine built in, so you can just stick in a cleaning disk, set it to clean mode, start it, have it built in. Because there's no reason. All you got to do is just like move the head back and forth to scrub it and then spin the disk. That's pretty simple. So I would like to have a lot of that built in to a thing. So we're going to need a microcontroller, but we needed to measure stuff. So yeah, I would like, we can continue this project, but I would like to continue on and have some more analysis stuff. So I think laying out a PCB for a probe interface would be a good idea. So you play MIDI files? No. I'm gonna be pretty strict about scope creep on this one, actually. I have some goals, but yeah, it's never going to be a flux imager. We're just gonna pop a grease weasel on. That's it. You could put a cryoflux on, whatever, it doesn't matter. But that's the kind of thing. It's not going to be anything else. This is a thing I might do. I might integrate a USB hub into it so that you can plug one USB cable in and then communicate to both grease weasels. Maybe that. But yeah, I have specific goals. Oh, also it needs to fit in a half height 5 1/4 inch bay. So that's a goal too. It's going to be a complicated one. So surprised nobody's added MIDI support to the Flash floppy firmware. I don't have, well, that's a GoTech. What do you want it to do? Like for one of the clicker things or something? I'm not sure what that would do even. But yeah, for something, I mean, like, yeah, the steppers are definitely noisy enough to be able to do something like that. Grease weasel. Oh, okay. Yeah. Yeah, I can see that. So I'm trying to think if there's anything else I should check here before we shut this down. So we usually end stream, for those who are new here, end stream at the next hour break, a 4-hour long stream. Just trying to think through everything we got here. This setup worked really well. By the way, got the mix up? Yeah, not a problem. This is the first time we set this up like this today. I'm happy with this solution. I wonder if there's a way I could, this is so stupid, split the DVI out from the VGA convert or scaler so that I could simultaneously capture VGA and HDMI. So dumb. Dogface? Yes. They're okay. They're pretty good. They're pretty good. You know why, right? Because he's like from here. Like big time AZ person. Okay, Alice Cooper actually had a radio show here, all right? This is like side note, all right? And he played Hocus Pocus by Focus, and that was just like mind-blowing. Okay, that was, I will never forget that moment, all right? That was incredible. Rushing your new truck that's gonna be get your plate. Yeah, I can see that. But yeah, anyway, I think we're gonna have to call that here. So Phil, thank you so much for helping me with the 16500C. I really appreciate that. It was fantastic to get some more hands-on experience with that, and finally learn something with symbol and decoding. It wasn't quite what I expected, but it was very beneficial. So I now know more what to expect from this thing. So yeah, that's very much some good experience to have. I wonder how symbols interact with like externally controlled stuff like the computer. I don't know. That's weird. That's more to look into later. All right, we're going to have to wrap this up, though, for today. We will come back tomorrow. Probably going to look more at this because we didn't make... Ben's probably right. Simple feature is probably more useful to the state listings. Yeah, I have a feeling I didn't show too much out of the manual for the state listings, but they look a lot more complicated. So, yeah, I think if we had a... There's no way we can clock this, unfortunately, because it's just controlling mechanisms. It's not like reading memory and stuff like that, so I don't really think there's anything we can do. Yeah, but if we could do way more. But that's fine, because I don't think we're going to get into that too much. I could possibly do it with VGA, with a horizontal sync. Maybe. That would be interesting if I could count the pulses where there's no video signal, and then before and after the VSync signal to just like calculate the front porch and back porch automatically. That would be kind of cool. Anyway. Yeah, all right. I need to go back to this computer so that I can access the server and actually start the outro here. All right. And someone had asked about being able to save the configuration stuff here. That is 100% possible. I should actually figure this out. Oscilloscope. Hold on. There is a way of doing this. Utilities, no. Hard disk. We're going to store to file. I'm going to say FDC Snoop. All right, done. And store state timing A. And execute. Continue. All right, there we go. I just saved the... Might as well just show you. There we go. So this is how you do it. So I set it to store the state and timing A configuration to this file, and you execute it. So now I can load that configuration from here. And then we could just do that. You, especially Phil here, may have noticed that my my color scheme is unique. So this is something that I think I'm pretty sure I set this up to have the gray background. So yeah, you can definitely do that kind of stuff. That was for the this area here. So yeah, you can change some of the colors here. So yeah, that is something that I already set. And for that, you set an auto load file here. This, I believe. So yeah, if you change that, then you set up that stuff. So anyway, let me switch to here, and I can shut down the system and then cut full power. All right. Yeah, it's a really powerful machine, but yeah, it is very early. So, all right. That is going to be it for today. So thank you all so much for being here and hanging out. And again, thank you, Phil, for the expertise on this machine. That was really, really nice to get more hands-on time with it and learn some of this stuff. Let me go ahead and shut off the power supply for the floppy drive while I'm thinking about this here. Because yeah, this was probably one of the better experiences I've had with that thing today. So really happy about that. But we are going to call that here. So if you enjoyed this, you might want to stop by again tomorrow because we're going to just continue this project. But you may want to follow the channel to be notified when I go live again next. If you want to help support the channel, you can find me on Patreon. But for now, that is it. And I will see you all next time. And oh yeah, I'm about to release a video. So there you go.